When we solve problems or we are working in a lab or we make a calculation, it's really useful to know either ahead of time what kinds of numbers are we expecting, or once we have a result, is this reasonable? Is this what we expect? So the first technique we're going to talk about for checking results or making approximations is dimensional analysis. So this is where we look at the units on a measurement or the variables in a problem, and then we try and kind of figure out what do we expect from our results. So some rules to know about with units. If you're going to add two numbers together or add two values together, they need to share the same units. I can't add kilograms to meters. I can only add kilograms to other kilograms. So if two things are going to be added together, they need to have the same units. When we multiply or divide two quantities, then we also need to multiply or divide the units. So if I divide 10 meters by 3 seconds, I get an answer that should have units of meters per second because I divided meters by seconds. At the end of your problem, make sure your units make sense. So if you're doing a calculation and you say, okay, I'm looking for how far it is from, one end of the school to the other, and if you get units of, you get kilograms as your units, that doesn't make sense because we don't measure distances in kilograms. If you got time, that may or may not make sense because it depends kind of how we're talking. There might be places where that might give you some indication of where you might have gone wrong. Second thing that we can look at for evaluation is order of magnitude and Fermi calculations. So order of magnitude is how many powers of 10 a number has. So if we have, for example, the number 1000, this has 3 powers of 10. We could rewrite this as 10 to the third. So the order of magnitude is how many of those tens are in that number. So scientific notation allows us to easily compare numbers. If I'm looking at, say, 6 times 10 to the third versus 3 times 10 to the second, I can easily see that the first number is 1 order of magnitude larger than the second because it's got an extra 10 in it. If you're feeling rusty with scientific notation, I'll try to pull a group of students together, everyone who wants to kind of review and ask questions, but otherwise I am kind of assuming that you're at least familiar with the basics here. The second thing to look at is Fermi calculations, and these are useful to estimate the order of magnitude of an answer. So what you're doing with Fermi calculations is you're just starting making some basic assumptions and trying to get roughly how big of a number should I expect at the end of this. And these are named after a physicist from the turn of the 20th century, Enrico Fermi, and just the idea of getting a rough idea of a calculation. And these are useful to, once you've, say, done a problem, to say, is my number in the right ballpark? Can I put some ideas to see about how big or how small it should be? So here's an example for you. How many steps are there to the top of the IGA building? So we could easily go in and count this, but what I'm going to do here is just do a rough order of magnitude calculation. So I know that there are, about 6 floors. So there's the ground floor to first floor to second floor to third floor to fourth to fifth to sixth. So there's about 6 floors in the building. And I'm just going to ballpark it that each of those floors we know has 2 landings, give or take, right? 2 of those flat areas between steps. And I'm going to say that each of those landings, so 2 landings per floor, I'm going to say that each of those landings has about 10 steps between them. So 10 steps per landing or between landings. So if I cancel out any of these similar units, so floors cancel, landings cancel, I end up with steps. So that's good because I'm expecting to have units of steps, and I get 120 steps. Now, does that mean I'm actually estimating there to be 120 steps? No. The important thing here is this magnitude. So we're talking about it should be on the scale of hundreds of steps, probably somewhere between 100 and 200 steps. If I got 80, I'd feel like, okay, that's reasonable. If I got 20, I might start to wonder because that's a whole order of magnitude off, right? 20 has 1 power of 10, 120 has 2 powers of 10, because this would be 1.2 times 10 to the second steps. So anything that has about 10 to the 2, we would say is probably pretty reasonable. That's the whole point of Fermi calculations and this, is to have a rough idea of how many powers of 10 are we concerned with. Let me know if you have any questions, but otherwise keep on working on whatever you have next.